Okay, all right. So this is the problem that we are dealing with. It's directly from your slide. The only difference is that what we are saying is that 18% of the gaps in lane B, lane A rather, are between 1 to 2 seconds. And then these are the parameters. And what we are trying to estimate is, how much time, if you're on lane B, how much time are you prevented from changing to lane B? So basically, you'll have to figure out, the total time that you'll be stuck in lane B, and then how much delay would it cause on that basis. Okay, so basically what you're saying is that, okay, if 8% of the gaps in lane gap are 0 to 1 second, so what we're going to say is, out of like how many gaps would you observe? Like if there are 360 vehicles per hour, you can say that you'll observe those 360 gaps, right? Between two consecutive vehicles, you will see 360 gaps, and they are between 0 to 1 second. So you can assume the average length of the gap is going to be between 0.5 seconds. And also the problem also stated that you require at least 1 second of time ahead of you and 1 second of time behind you to be able to make that lane change. Okay, so you require 1 second ahead of you and 1 second behind you if you want to merge onto a vehicle. So you need at least a 2-second gap between lead and lag vehicles so that you can merge in. So you need 1 second ahead, 1 second behind. So for the 8% of the gaps that are less than 1 second, you can say that the average time there, the average length of that gap is 0.5 seconds, right? So this basically the average of between 0 to 0.1. So essentially, you could say that how many gaps are you wasting in that scenario? Because 8% of the gaps are are 0 to 1 second. You're essentially 0.08 times 360 gaps are something that you cannot accept. There's no way you can accept that gap because the gaps are too low, right? You cannot change lane during those times. So that would be about, if you make that calculation, so if you can have your calculator out and give me that number. So about 28.8, is that right? You have to check my math here. So I'm going to just say 29 gaps. Okay, so 8% of the gaps are less than 1 second, so I can't use those. Okay, and then I have 18% of the gaps are 1 to 2 seconds. So I'm going to do 0.18 times 360. Because remember, because there are only 360 vehicles per hour on lane A, that means I'm going to have 18 times 360. And what does that number come out to be? 65? So about 65 gaps. So these are the two gaps that I absolutely will not be able to take, right? Yes.
I think it's that 18% vehicles have gaps. 8% covers.
Yeah, so actually that's what I was saying. Like I should have said there that 18% of the gaps are between 1 to 2 seconds. And that's the difference. I need to correct that problem there. So it's the gap between 1 to 2 seconds. But you can, even if that were to be the case, then that way you could just start with that 18%. So, there are 18% of the gaps you cannot accept. Okay. But still the breakdown between how many gaps are 0 to 1 second and how many gaps are 0 to 2 seconds is going to be important because of the next steps, because you want to figure out how much time is basically being lapsed, how much time that you're stopped from changing the lanes. Okay. Because how much time you're stopped for a gap that's less than 1 second. Okay. On average, you leave, because it's a gap of 1 second. So on average, you lose 0.5 seconds. On average, you lose 0.5 seconds on every gap that's less than 1 second. Okay, so on average, because some gaps will be a little bit larger, some will be a little bit smaller. So on average, you lose half a second on every one of these 29 gaps. Okay, so the time that you lose is 29 gaps times 0.5 seconds per gap. And that would be about 14.5 seconds. But on the longer gaps between 1 to 2 seconds, you will lose 65 gaps times 1.5 seconds per gap. Okay, because it's 1 to 2 seconds gap between there. So you're going to lose about 1.5 seconds per gap. And that comes to about what? Does that sound right? 97.5 seconds? Okay. Please check the math. Don't trust what I'm doing here because I'm not doing it with the calculator. Okay. So 15 times 65, so 1.5 times 65 gives me about 97.5 seconds. So I'm losing that much time on my, thing. So, and then also, can you figure out if you have 360 gaps, so you have 360 vehicles per hour, so you're creating essentially, you're choosing between 360 gaps. How many gaps are acceptable? So I'm going to write down number of acceptable gaps. Number of acceptable gaps would be, the total gaps are 360. Out of those, 29 I cannot choose because they're less than 1 second. 65 I cannot choose because they are between 1 to 2 seconds. So what does that come to? So I'm not able to choose about 94 of these gaps. So I should be able to pick about 266 gaps. Okay, please check the math here. So you're able to actually choose between 266 gaps. Okay. If you, yes.
So just to clarify, the number of acceptable gaps, is that going from lane B to lane A or lane A?
No. So you're always going. So the idea is that because lane B is moving at 40 miles per hour and less than the overall traffic stream, so you're trying to move from lane B to lane A. So the target lane is lane A. And that's why you're doing all of your analysis of gaps on lane A, because that's where you want to get to. Right? So the question was like, which lane are you referring to in terms of like, what maneuver are you talking about? So I'm talking about a maneuver to lane change from B to A. Okay, and that's why I'm analyzing all the gaps on lane A. So I'm not worried about, because I'm always worried about gaps in the target lane that's moving faster in these types of scenarios. And I'm trying to estimate the delay that will be causing. Okay, so you got 266 gaps that are acceptable. So, and then we said that you require 1 second of lead and 1 second of gap behind you. So how much clearance time would you take if you were to accept one of these gaps? How much time on lane changing itself? So how much time could you spend on lane changing itself? You require 2 seconds, right? Because you require 1 second ahead and 1 second behind. How much time would it take then? You have 266 gaps, and every gap requires 2 seconds to be accepted. Okay, so you will be time spent on so you can say, you can also call it the clearance time. So once you decide to make that lane changing maneuver, you can make an estimate of clearance time because every lane change requires 1 second ahead and 1 second behind. It's going to be 266 times 2. And then you could estimate that to be what, 532 seconds. 266 times 2 is 532 seconds. Yes.
So are you assuming that even if there's 266 acceptable gaps, that only one car that wants to change lanes is going to take each gap?
Yeah, you're basically analyzing that from one, because every vehicle is a target lane, right? I mean, every vehicle is a subject vehicle. Every vehicle on lane B could be a subject vehicle. So we are just analyzing this based on one vehicle so that we can then generalize, okay, what's the condition that one vehicle is facing? And then basically everybody who's on lane B in that scenario is essentially facing the same situation. They're finding the same gap scenarios on lane B. regardless of where you are on lane B, you face that same situation. You will face within that 1 hour period, there will be some gaps that are too small, some gaps are still too small. So there's less than 1 to 2 seconds. So you will all encounter those. And then if you do decide to make lane change, then that gap won't be available to any other vehicle at that point.
But like, even if one gap is like 10 seconds, it's kind of like taking that into account because we're just finding like an average like time.
No. So gaps could be larger than that. So the question is, what if a gap is of 10 seconds, right? But what we are saying is that even if the gap is 10 seconds, you're only going to utilize 2 seconds of that time because it requires you to have 1 second ahead and 1 second behind. If you have extra, that's not really material to you, right? If you just require 1 second ahead and 1 second behind, you are only going to be using 2 seconds of that time to make your lane changing. Okay, because what we are hoping, or what we are thinking here is that everybody who's on lane B has made a tactical decision that they want to get into lane B. So that's the limiting scenario, right? We're trying to identify what's going to be the delay if drivers want to maximize their speed and want to get into lane A somehow, or like, so that's like, but if they choose not to make lane change, then obviously there's no delay, right? The delay is only defined by, are you able to travel at your desired speed versus not? So when you're trying to estimate that average delay, you assume that the drivers want to go at that speed. So that means anybody who's on lane B wants to get to lane A, but they won't always have the opportunity. And all we're trying to figure out here is that because they don't have that opportunity, how much delay does it cause? Assuming everybody from lane B wants to get into lane. So let's think about this. So number of gaps that are acceptable is 266 gaps. An average clearance time will be 532 seconds. So what will happen is that you're not going to be actually allowed to change lanes for, so subject vehicle can't lane change. Subject vehicle cannot lane change. What times? Subject vehicle cannot lane change is for this 14.5 seconds. They cannot lane change for this 97.5 seconds. Okay. And they cannot lane change when somebody is actually changing lanes. It's 532 seconds. Okay. So essentially, what they cannot do, so they cannot lane change between 14.5 plus 97.5 plus 532 seconds. So you cannot lane change for this much time. You cannot lane change for this much time. And what does that add up to? Can somebody give me that number? So 97 plus 14 is 111, 112, 644. Okay, 644. So out of the 3,600 seconds available, you cannot change lanes for 644 seconds. And the rest of the time, you're free to make lane change. Okay. Now, whether or not you do, that's not what we are considering here. We're considering if everybody wanted lane change, they will be limited within 1 hour period. There will be 644 seconds such that you cannot make that lane change. Okay. So based on the 654 seconds, and you can figure out essentially what we call a blockage length. Blockage length is basically what length of the highway is blocked because you cannot change lanes for 644 seconds. Okay, and that's easy to do. Blockage length, I showed you the formula on the slides, which is capital T times VS over the number of gaps, number of acceptable gaps. Okay, so capital T here is 644 seconds. The stream of traffic speed is 50 miles an hour. Okay, so you have to do some unit adjustment here. So I'm going to just divide that by 3,600 so that I have the miles per hour going. 50 miles per hour is the speed. And the acceptable gaps that I have, what was my acceptable gaps that I had? 266 gaps, right? So what does that give me in terms of the blockage length? So 644 divided by 3600, I'm dividing by 3600 so that I can get that unit squared away because my speed is in miles per hour and my gaps are in seconds. And then number of acceptable gaps is 266. So my blockage length comes to what? Point 23, 0.03. Okay, about that. Okay, that's about right. That sounds good, I guess. Yeah, that's. Can somebody verify that? Yeah, that would be in miles. Remember, because we converted that into seconds. If you want to get into feet, you can obviously apply that factor of 50 to 80 to it and get that into feet. But for now, let's go with miles because our goal is to actually get the average delay. And that formula also I showed you on the slides, which is half times BL divided by VR. Remember, now we are using, why we are using VR, the relative speed here. Because this blockage length is not something where you're completely stopped on the highway. It's just that you cannot go as fast as the stream. So VR is the relative speed between average stream of traffic minus the speed that you can maintain while you're stuck in lane B. So remember, on lane B, the speed was 40 miles per hour. Okay. The speed was 40 miles per hour. Your average speed is 50 miles an hour. So your relative speed is only 10 miles. So the speed that you lose during that blockage length is only 10 miles an hour. So the average delay would, in this case, would be 1/2 times 0.03 divided by relative speed. So 50 minus 40, because VR is what I'm after here, relative speed, 50 minus 40. And that'll equal to, what does that come to? Or 0015? 0015. And that, what are the units are going to be on this? Oh, right. That's perfectly right. That's good. You're going to have a limit of 0.0015 hours. Okay. And because the limit is 0.0015 hours, you can convert that back into seconds by doing what? Multiplying it by 3600, and you'll get about 5.5 seconds or something, give or take. So yeah, so if you want to convert that into hours, the final answer convert to seconds is 0.0015 times 3600. It's about 5.5 seconds. And that's not a big delay, right? Because the speed differential is not as large between the two lanes. It's about only a 10 miles per hour difference. And you could see the average delay, if you were to sort of, increase the difference or like, so you could think about if your blockage length increases, if your blockage length goes up, then you will see that, you'll have sort of, and blockage length is dependent upon, blockage length will increase if the blockage length will go up if the stream of traffic was larger. Okay. If this speed was larger value, then your blockage length will increase and that will lead to more delay. Okay. But in this case, the delay is about 5.5 seconds. Your traffic stream speed was like 10 miles an hour difference, and your traffic was only moving at 50 miles per hour. So this is just one calculation that you could make to estimate what will be your delay because of the lane change. Now, this is not going to be part of your midterm because we just covered it today. So don't worry about this stuff for this midterm. I will go over some of the muddiest points because I've run out of time here. I will go over some of the muddiest point survey questions that I got online, and we can discuss all the homework problems and stuff like that, and some more things about the test right as we start the lab. Okay, and don't worry about submitting what was deliverable today for the lab. I will just extend everything by 1 week, so you have some time to kind of think about the test and so forth. With that, I'll stop here and I'll see you at noon. Okay, let me know if you have any questions. I'll post this video online.
Professor,
Yes.
is that 1 second clearance ahead and behind value and also that average loss of 0.5 seconds, are those assumptions that we make with every problem?
Yes, you will make those assumptions. Like I could give you different assumptions with regards to. So the question is, do we make that 1 second ahead and 1 second behind assumption for every problem? That I can modify. But yeah, so if you want to just figure out how much time is wasted on each gap, that assumption is reasonable to kind of take the midpoint of those gap lengths.